Completing the square then. This is another thing to do with quadratic. So we have this particular one. Yes, it does factorise, but I use it as an example so we know what it's going to. If I want to, let's imagine I don't know the quadratic formula. Oh geez, how do I do this? I could complete the square. Basic idea behind completing the square, we get the constant and we move it to the other side. Then on the left hand side, I add, well actually on both sides for that matter, what you do to one side of the equation you've got to do to the other. So on both sides of the equation I add half the coefficient of x squared. That pause is important. Half the coefficient of x squared, because if I didn't pause I'd go half the coefficient of x squared and then I'd add half to each side, and that of course wouldn't be right. So half the coefficient of x squared. So we can add 3 squared, there it is. And what we've done on the left hand side is create a perfect square, so now we complete the square and it becomes x plus 3 all squared. Well, we know that if something squared is 16, it must either be plus or minus 4. We can now go and find the two answers. So that's the idea behind completing the square. It is indeed where the quadratic formula comes from. So if we had ax squared plus bx plus c, using that same idea, well, the a in front of the x squared is a bit awkward, so I'll just divide everything by a, so it's a nice monic. I'll move the constant to the other side. Then we'll add half the coefficient of x squared. That means I've now completed the square on the left hand side. I get x plus b on 2a all squared. The right hand side I've got an algebraic fraction. Ooh, it's starting to look familiar. Top of the fraction becomes b squared minus 4ac over 4a squared. Therefore it must be plus or minus the square root of that right hand side. Move the b on 2a over, and there's our quadratic formula. Another way of thinking about completing the square. X squared minus 6x plus 6. The way I could do it is like this. I say, well look, I know I'm going to complete the square. I just look at the algebra there. I'm not worried about the constant. And I know it's going to end up being, I'm going to get x and then half the coefficient of x inside those parentheses. Half the coefficient of x is negative 3. I know I've got x minus 3 squared, but of course, if I was to expand that out, I wouldn't get 6. I'd get 9, so I must end up with negative 3 there. And I can now look at that and say, hey, I've got the difference of two squares. It must be x minus 3 plus root 3, x minus 3 minus the square root of 3, and so my solutions are x equals 3 minus root 3 or x equals 3 plus root 3. In fact, when we start dealing with imaginary numbers, it then means every quadratic can be written as the difference of two squares. Okay.